If our moral instinct and guilt along with it are inherited, do you foresee a way in the future to pinpoint that? This gene does this or this gene does that?
When people make an argument about the role of biology in a particular psychological phenomenon like morality or language or these very complicated phenomena, I think there are several steps that need to be taken along the way before we can even get to the genetic level. The first is to break down these complicated phenomena in terms of component pieces that we can ask about. So, for example, when we say what's entailed in moral judgments, well, there are a million things involved in moral judgments. So the way we begin to think about it is to decompose the system into things like, well, if you're a moral agent, you need to distinguish between an intentional action and an accidental one. So I take a rock and I throw it at you and it hits you in the face and it hurts you. That's not okay morally. I have a rock in my hand, I trip and the rock goes off and hits you in the face. The consequences are identical, but from the perceiver's perspective, I didn't do anything morally wrong unless I was negligible. Like I saw the banana peel on the floor and I knew I was going to hit it and I still went ahead and tripped. That's negligence. So there's a whole layer of psychological distinctions there that go to evaluating consequences that depend upon the means, depend upon the path to the consequences. So here's where we can ask, for example, an evolutionary comparative question. We can say, do animals distinguish between consequences that are accidentally driven versus intentional? And we're beginning to get answers that the answer is yes. Now that doesn't make them moral creatures, but it means they have some of the building blocks that would be necessary for becoming one. Once we begin to find systematic similarities and differences in those components, then genomic analyses between these species can begin to refine how we understand the genetics of those processes. Now, that's a long way away. I mean, people have made a big deal about the FOXP2 gene and its relationship to language, but what's often forgotten in that discussion is that the FOXP2 gene is linked not just specifically to language, but all sorts of patterns of motor operation in the face. It's not specific to language, but it has effects on language. So we're very far away from that. But I think, to me, the combination of rich behavioral descriptions of both humans and non-human animals, as well as developmental cases, studies of brain damage and studies using brain imaging, and genomic analyses, that combination is going to begin to allow us to refine our understanding.